There is a conversation happening in the back rooms of independent appliance repair shops all across Britain that the manufacturers do not want you to hear. It starts the same way every time. An engineer opens up a machine. It is 3 years old, maybe 4. It has been sent in for a bearing failure or a control board fault. He looks inside, he prices the repair, he does the maths, and then he makes a phone call to the customer that goes something like this. The cost to fix your machine is more than the cost of replacing it. I am sorry, there is nothing I can do. Then he goes home. And when his own washing machine needs replacing, when his own fridge gives up, when his own dishwasher stops cycling correctly, he does not go to Currys. He does not go online and order the newest model with the best energy rating, the app connectivity, and the 15-minute fast wash program. He finds a machine from 1987, or 1993, or 2001. He services it. He puts it in his kitchen, and it runs. That is not nostalgia. That is professional judgment from someone who has opened up both machines and knows exactly what is inside each of them. That is an engineer who has spent a career watching the British appliance industry move from building things that last to building things that do not, and who has made the only rational decision available to someone with that knowledge. Today we're going to tell you what they know, and why it changes everything about how you should think about buying an appliance in Britain in 2026. Before we dive in, comment where you are watching from, and click subscribe. The UK generates 1.65 million tonnes of electronic waste every year. According to the UN Global E-Waste Monitor, that makes Britain the second largest producer of electronic waste per capita in the entire world, second only to Norway. Large household appliances, the washing machines, the fridges, the dishwashers, account for the single biggest category of that waste. Over 167,000 tonnes of large appliances were collected as WEEE in 2024 alone, every quarter. Machines that could, in another era, have been repaired and kept running for another 5 or 10 years. They are not being repaired, they are being replaced. And the reason they are being replaced is not that they wore out. It is that somebody in a corporate engineering department made a series of decisions about materials, about drum design, about parts pricing, about circuit board architecture that made repair economically impossible before the machine reached half its potential lifespan. The engineers who work on these machines every day know this. They have known it for years, and a growing number of them have made a personal decision that tells you everything about the state of the British appliance market. They have gone back to old machines, and they are not coming back. Here is what this investigation is built on. Which magazine, in a piece of research that the appliance industry largely ignored and the consumer press barely covered, physically dismantled a selection of modern washing machines from the UK's major brands and compared them to machines from the 1980s and the 1990s. The brands involved in the modern teardown included Bosch, Beko, Indesit, Miele, Hotpoint, AEG, and Zanussi. They took the machines apart component by component, they documented what they found, they photographed it, they published it. The conclusion from which laundry expert Adrian Porter was direct. The majority of modern machines have sealed drums. The traditional metal tub has been replaced with a plastic one, welded shut, sealing off access to both the drum and the bearings. If the bearings fail, which is one of the top 5 most common problems with washing machines according to the annual reliability survey published by Which, you may have to replace the whole machine because it is uneconomical to repair. And then he said the line that should have been on the front page of every consumer newspaper in Britain. None of the machines from the 1980s and the 1990s that they dismantled had a sealed drum. Not one. We also drew on long-term failure data from independent UK repair engineers, parts availability and pricing research, the UK's e-waste statistics from WeData published by DEFRA and Material Focus, and the government's own right to repair legislation and its publicly documented failures. We looked at what engineers working in the repair sector actually do when they are spending their own money. That is the most reliable data point of all. People who spend their professional lives understanding these machines and who have no financial incentive to sell you a new one. Some of what follows certain manufacturers will dispute. That is how you know that it is accurate. To understand why engineers are going back to old machines, you need to understand what those old machines actually were. In the 1980s, a British washing machine was a metal drum inside a metal tub, split into two halves and bolted together with 10 to 12 screws and a rubber seal. When the bearings failed, and they did eventually fail because bearings always do, a repair engineer would arrive, unbolt the front half of the drum, pull the old bearings out, press new ones in, reseal it and leave. The parts cost under £20 at today's prices. The repair cost under £100 in total. The machine would run for another 5 to 10 years without incident. The drum itself was made of stainless steel, not a thin stamped shell, but a proper steel construction built to withstand tens of thousands of wash cycles at high spin speeds without fatigue. The motor was a simple induction motor or a carbon brush motor that an engineer could replace with tools he already carried in his van. The control system was a mechanical programmer, a rotating timer that controlled each cycle. When it failed, a replacement timer cost around £15. The repair took 30 minutes. There was no proprietary software. There was no paired circuit board that needed calibrating after replacement. There was a timer, a drum, and a motor. Any engineer in the country could fix any of them. These machines did not have 27 wash programs. They did not connect to an app. They did not sense the load weight and adjust the water level automatically. What they had was a mechanical simplicity that made every failure point accessible, every repair affordable, and every part available from any decent parts stockist in the country. The machine was designed on the assumption that it would be repaired. That assumption shaped every engineering decision that went into it. That assumption is gone. Then two things happened simultaneously and they ruined everything. The global appliance industry consolidated into a small number of corporations. 6 groups now control the overwhelming majority of the UK appliance market. Arclick owns Hotpoint, Indesit and Beko. Haier owns Hoover and Candy. BSH owns Bosch and Siemens. Electrolux owns AEG and Zanussi. And once consolidation removes genuine competition, the engineering priority shifts. It is no longer about building the best machine you can. It is about building the machine that maximizes the revenue yield per customer over a 10-year ownership window. And the best way to maximize that yield is to make repair expensive, parts proprietary, and replacement inevitable. At the same time, the shift to plastic components and electronic control systems created appliances that were genuinely more feature-rich but fundamentally less repairable. Mechanical programmers were replaced by printed circuit boards that cost £150 to £220 to replace, and are often paired to the specific machine's drum electronics, meaning a second-hand board from a scrapped machine will not work. Steel tubs were replaced by plastic ones, and those plastic tubs, instead of being bolted together, were ultrasonically welded shut. Not because welding produces a stronger drum, because it produces a drum that cannot be opened without destroying it. A drum that, when the bearings inside it fail, must be replaced in its entirety at whatever price the manufacturer decides to charge. The engineers noticed this change happening across multiple brands within a remarkably short window of time. Brands that should have been competing against each other all made the same engineering decision within 12 to 18 months of each other. Some manufacturers even left the original screw holes in place on the drum housing and then welded the joint shut anyway, as if someone could not quite bring themselves to remove the evidence of what had been there before. Here is the specific engineering detail that the industry does not want discussed in public. The bearings inside a modern sealed drum washing machine are standard industrial components. The rear bearing on a typical machine retails for £4 to £5. The front sealed bearing costs around £5. The drum seal costs under £2. Total parts cost to rebuild the bearing assembly under £15. This is not a specialist component. It is a standard bearing available from any industrial supplier in the country. It costs less than a takeaway meal, and it takes a competent engineer 90 minutes to replace. The sealed drum assembly that makes those bearings inaccessible costs on the manufacturer's own website between £200 and £500 depending on the model. On one specific Bosch Series 6 machine retailing at £549, the drum assembly alone is priced at £493. The drum costs almost as much as the entire machine. That is not a spare part price, that is a replacement trigger. The manufacturer has set the price of repair to make it indistinguishable from the price of replacement. That decision was made in an engineering boardroom before the machine was ever assembled. The right to repair legislation that came into force in the UK in July 2021 was supposed to address this. Under the law, manufacturers of washing machines, fridges and dishwashers must now make spare parts available for 7 to 10 years after a model is discontinued. It sounds like a victory for the consumer. It is not. The law contains no cap on the price manufacturers can charge for those parts. A drain hose on a Miele appliance was quoted at over £300 in a Which survey from June 2025. Samsung's recommended call-out charge for a laundry or refrigeration repair is £149 before any parts or actual repair work has been carried out. The law also allows manufacturers to bundle multiple components together, forcing you to buy an entire assembly when you need only one small component within it. A pump motor for a Samsung dishwasher retailing at £449 was found to cost £131 as a replacement part before the £149 call-out before labour. On a machine that cost £449, the repair is not possible at a price that makes economic sense, and the law does nothing to change that. The legislation also covers only certain appliances. Tumble dryers and cookers are excluded entirely. And crucially, since Brexit, the EU has expanded its equivalent directive to cover smartphones and tablets. The UK has not followed. Our right to repair law, already described by its own critics as not a right to repair at all, was already falling behind Europe. In a June 2025 Which survey of 126 owners who had attempted a repair since the legislation came into force, a lack of spare parts still prevented successful repair for 1 in 10 people who tried. The law passed, the engineers shrugged, and then they went back to buying old machines. Drop a comment right now. Tell me what appliance you had repaired in the last 3 years, what it cost, and whether you went ahead with it or bought new. My prediction is that a significant number of you are going to say the repair quote was more than half the price of a new machine. I'm also going to predict that a meaningful number of you will say the part you needed was either unavailable, on a 6-week back order, or only available as part of a bundle that cost 3 times the component you actually needed. That is not a supply chain problem, that is a business model. So what are the engineers actually buying when they go looking for old machines? And what does that tell you about what to look for? The machines that engineers consistently seek out fall into a narrow window, roughly 1985 to 2005, old enough to have metal drums and mechanical or early electronic controls, new enough that parts are still available from the specialist second-hand market and some manufacturers. For washing machines, the names that come up repeatedly among repair professionals are older mill models from the 1990s, machines built to that era's engineering standard, with split drums, steel tubs, and a design philosophy that assumed the machine would need to be serviced rather than replaced. Older Bosch and Siemens machines from before the drum sealing trend took hold. Early Zanussi and AEG machines from the same period, before the Electrolux acquisition changed the engineering priorities. And Speed Queen, the American commercial laundry brand that never adopted the sealed drum design and still builds machines to a commercial specification, machines that are tested to 25 years of use under commercial laundry conditions and can be found through specialist UK importers. These are serviceable machines. For fridges, the picture is different. The critical component is the compressor. The single compressor and single thermostat fridges of the 1970s and the 1980s with no ice maker, no water dispenser and no inverter board are the machines engineers describe as genuinely serviceable. The compressor is accessible. The thermostat is a mechanical device that any engineer can replace in 20 minutes. The door seals are standard sizes available from any commercial refrigeration supplier. When something fails, it can be fixed for a fraction of what it costs to repair a modern appliance with a failed inverter compressor and a dead control board that together cost more than the machine did in new. The broader lesson is not that you should go and buy a 30-year-old washing machine. It is that the engineering principles of that era, accessible components, standard parts, repairable design, a manufacturer that assumed the machine would need to be serviced, are the benchmark against which every appliance purchase decision should be made. And the only manufacturers in the current market that still build to anything approaching that standard are the ones who have refused to adopt the sealed drum, the proprietary parts network, and the replacement cycle business model. Here is the maths that the industry does not want you to do. Option 1. You buy a mainstream sealed drum washing machine for £500. It runs 5 to 7 years. The bearings fail. The drum replacement quote comes back at £350 to £450 before labour, beyond economical repair. You buy another machine, another £500. 7 years later, the same thing happens again. Over 15 years, you have bought 3 machines. 3 call-out charges at £80 each. 3 sets of delivery and installation fees. Total spent well over £1,700. Option 2. You find a well-maintained machine made before 2000, a Miele or early Bosch with a split drum, serviced by a qualified engineer before purchase. Call it £200 for the machine and £150 for the service. Bearings fail at year 8. Repair cost under £100 including labour. Total over 15 years, under £500, and the machine is still running. Option 3. You buy a current Speed Queen or new Miele at £800 to £1,400, repairable drum, parts available, designed lifespan of 15 to 20 years, 1 service call in year 10 at £90, total over 15 years, under £1,500 and falling. The mainstream machine is the most expensive purchase in the room. The mainstream machine is the most expensive because of what happens after you take it home. The sticker price is the smallest number in the transaction. Nobody in the showroom tells you the other numbers. Here is what engineers know that the showroom will never tell you. Rule 1. The energy rating on the label is not the cost of the appliance. The AAA+ energy rating that manufacturers use to justify a premium pricing saves you approximately £30 to £50 a year on your electricity bill, compared to a machine rated A+. If the machine fails at year 5 and costs £400 to repair beyond the economic threshold, the energy saving never catches up. The total cost of ownership, purchase price plus repair costs plus replacement costs over 15 years, is the number that matters. The energy label is a marketing tool, it is not a financial plan. Rule 2. Complexity is not quality. Every additional feature on a modern appliance is an additional failure point. The ice maker that accounts for 50% of all fridge service calls was not added because consumers needed ice. The Wi-Fi connectivity on a washing machine was not added because consumers needed to start a wash cycle from their phone. These features were added because they sound impressive in a showroom and because they create service revenue. The engineer who has stripped out 1,000 ice makers over a career will tell you the same thing every time. The simpler the machine, the longer it runs. Rule 3. Before you buy any appliance, ask one question. Can an independent engineer repair this machine outside the manufacturer's warranty network, using parts that are independently available, at a price that is less than 50% of the machine's purchase cost? If the answer is no, and for the majority of mainstream appliances sold in UK retail today the answer is no, you're not buying an appliance. You're entering into a replacement contract with a company that has already calculated when you will sign the next one. The UK is the second largest producer of electronic waste per capita in the world. Not because British households are careless, because British households are being sold machines that are engineered to be discarded. Large household appliances generated 167,000 tonnes of electronic waste in 2024 alone. Every one of those machines contained metal, plastic, refrigerant, and electronic components that required energy to manufacture, resources to ship, and infrastructure to dispose of. Every one of them could, under a different engineering philosophy, have been repaired and kept running. The engineers who go back to old machines are not making a statement about nostalgia. They are making a statement about value. They open up a machine from 1992 and they see a rear bearing that costs £4.50 and can be replaced in 90 minutes with a standard set of tools. They open up a machine from 2022 and they see a sealed drum that costs £400 and cannot be opened without destroying it. They know which one was designed for the consumer and which one was designed for the replacement cycle. Now you know too. If this video just changed the way you think about buying an appliance, subscribe now and share it with anyone who's about to walk into a Currys. That is all.